Hi everyone, I'm the team leader of team number 3, and today we are viewing the thermal stress and phase changes. Our class is Ondas y Calor, or Physics 2. Our team members are Dana Sofía Rivera Rivas, me, Miguel Ángel Díaz Sánchez, Erika Alejandro Treviño Almaguer, Mauricio Arnondo Vázquez Zavala y Ángel Gabriel Chávez Parra. Our index would be the introduction to heat, what is thermal stress, formula for thermal stress, thermal expansion, everyday examples 1 and everyday examples 2, industrial applications, breaches, expansion joints, thermal shock in glass, what is a phase change, types of phase changes, heating core, latent heat, example, boiling water. Another example, it would be melting ice, phase diagram, relationship, relationship between thermal stress and phase change, extreme examples, pipe freezing, conclusions, and questions. Okay. Mm, Okay, introduction to heat. Heat is a form of energy that is transferred between bodies due to a difference in temperature. It always flows from the object, higher temperature, to the one with lower temperature, until both reach thermal equilibrium. This process of energy transfer is fundamental to understand these numerous phenomena in daily life, from how a pot is heated on the stove to how an engine works. Why why material expand, or how the human body maintains its temperature. Heat should not be confused with temperature. Temperature measures how hot or cold a body is. Heat is the energy that moves from one body to another due to that temperature difference. Additionally, heat can be transferred in three main ways: conduction, convection, and radiation, which explain how it spreads in solid, liquids, gases, and even vacuum. What is thermal stress? A thermal stress or mechanical stress is caused by a temperature change that prevents a material from expanding or contracting freely. This can happen when temperature changes uniformly or non-uniformly, leading to physical damage like cracking, warping, or buckling if the material strength is exceeded. Factors that can composed by air temperature, relative humidity, wind speed, solar radiation, or heat sources. The thermal stress formula would be that one on the left. Okay. The thermal expansion explains how bodies increase their dimensions when temperature rises and decreases when it falls. Linear expansion on length, used for bars, rods, wires, tubes, templates, diameters, ready, etc. And it would be that the formula now new length. New length would be the formula that length equals initial length plus delta length. For surface expansion or area used for sheets, plates, and metal surfaces would be that volumetric expansion are volume used for 3D solids, liquids, gases, between within containers, etc. And that would be its corresponding formula. Expansion of openings. Holes, it ho- uh, holes in plates expand just like the material. And that would be its formula. Now, expansion with thermal stress. We're not allowed to expand. Doesn't mean it means like the materials it's not allowed to expand. Now we are going to see some examples of them. These are some crucial things to understand how it works with our daily life, like going to the street and watching the bridges or just walking around. Number one, linear expansion. It would be lengths, diameters, and radi. Rail, railroad tracks. On hot days, the rail expands, and that's why spaces are left between them. If not, it would bend. That means, mm, that means they are left with some space. If not, it would bend like this. But they would break down because it would have a lot of pressure. So it would break. It would be some something awful. Now electrical cables. Cables are tighter in cold and looser in heat because they expand. Metal jars, metal jars lids. To open a lid, we put hot water on it. The diameter of the lid expands and it loosens. What does it mean? Well, sometimes when you have like a pickles jar and you can open it, some person some persons uh, put it on some heat so it would loosen its tighten. Another example would be the surface expansion areas, like metal plates that curve. When one face is heated more, for example in the sun, that face expands more than the plate bends. Pavement cracks. Asphalt expands with heat and contracts with cold, which is why expansion joints appear.
Expansion joints. Expansion joints are separations or special space that are left in the structures of bricks to allow them to expand and contract due to temperature change. All material expands when it's hot and contracts when it's cold. If a brick were a single rigid piece with spaces, when directly cool could crack, deform, or even collapse due to enormous internal forces. What function do they have? 1. Allow thermal expansion of the concrete and steel of the bricks. 2. Prevent structural damage produced by internal pushes or tension. 3. Maintain the safety and stability of the bricks throughout the year. 4. Reduce the risk of retrieval or displacement of displacements. Why, why are they necessary? Bricks are exposed to low temperature variation. Along bricks can lifting several centimeters or even tens of centimeters on very hot days. Joints allow that movement to occur without damaging the structure. What do we see in daily life? When you drive over a bridge in a car, sometimes you feel a small boom or vibration. That's an expansion joint with metal or rubber plate. Thermal shock in glass. Thermal shock is a phenomenon that occurs when glass undergoes a sudden change in temperature, either heating up or cooling down suddenly. This rapid change causes some areas of the glass to expand while others contract, generating internal tension that can use the glass to crack or even fracture suddenly. Why does it happen? Glass, like most materials, expands with heat and contracts with cold. The problem appears when one part of the glass heats up quickly; it expands, while another part remains cold; it doesn't expand equally. This creates a strict imbalance within the material. If the stress exceeds its internal resistance, the glass breaks. What is a phase change? A phase change by which a substance passes from one physical state to another, solid, liquid, or gas, due to a heat exchange, without its temperature changing during the process. What causes them? Phase changes occur when a substance absorbs or releases heat. Absorbs heat, fusion, vaporization, sublimation. Releases heat, solidification, condensation, and deposition. This heat is called latent heat and is used to break or form mantle. That's why temperature doesn't change while the phase change occurs.
Now we're going to talk about the heat curve. The heating curve is a graph of temperature in relation to the amount of heat added. The heating curve shows the temperature change that caused the substance to absorb an increased amount of heat. We can also observe that the temperature remains constant, while the change of a state is in progress. The temperature stabilizes because all the heat energy is used to break the intermolecular forces. Normally, it's graphed like this image right here, and it's two things. The x-axis uh, is the amount of heat added, and the y-axis, temperature, that is the temperature. As heat is added, the substance goes through stage where first the temperature increases, that are the inclined lines. Here, heat causes particles to move faster, so the temperature rises. One example of that is a solid heating up before melting, a liquid heating up before boiling. A phase change occurs during fusion or evaporation. Its heat is absorbed, but temperature does not change. That incoming heat is used to break bonds between particles, not to increase temperature. It's called latent heat. Now we are going to talk about the latent heat. Refers to the energy required by a substance to change state when this change involves going from solid to liquid phase. We speak of latent heat of fusion, and when the change occurs from liquid to gaseous state, we speak of latent heat of vaporization. This is his formula, and an example of this is if heat is applied to a piece of ice and it begins to rise in temperature upon reaching 0 degrees, the change from solid to liquid state will occur. This temperature will not vary, even if heat continues to be applied until the ice has completely melted. Once melted, The water will begin to rise in temperature again until reaching 100 degrees, where the phase change to vaporization occurs, maintaining stable temperature until the water completely evaporates.
Relationship between terminal streets in the phase change. How are the relative in CCI, the energy of the phase change can generate terminal stress when a material changes by phase, its volume increases in or decreases abruptly. The change in volume produce expansion or contraction, which can generate internal tensions. Examples: water expansion when the phase is negative 90%. If this side close by the container, this expansion generates enormous stress that can break the material. Metals contract strongly when to solidity. In casting, this contraction creates internal stress that the process cracks. In Sys B, terminal stress in the case local face the changes of in the changes. If the material receives intense heat in the point that area can head of vapor reach in metalling or bonding before the reset place in unevenly. The unitool in expansion or contractions general terminal stress that the fracture of material. Example, heading class the borderland in the point can't meet of the stand of the area and while in the wild reset stays cold. Caroline tensions that make burst. In C3, both the phenomenon, the point and the head transformer, both the phenomenon straits in the changes occur because the material absorbs the losses head has limited thermal conductivity in response with volume change and the state of the tensions. General conclusion. Head in the terminal straits and the phase change in the fundamental concepts and explained how materials in the steam systems respond out to the temperate variant in the bone natural. E and the enjoy in void events. So the study of the head transformer temporal spans in mechanisms of the transients when understand that the impurity does not simply affect how the hot or the cold an object feels. It determines how the matter behaves um, in structural and molecular level. Terminal expansion reveal how the materials change dimensions with the parent turret, often producing internal straits that deform the fractured structures even when expansion is restricted. Everyday exams so the railroad tracks break the expansion holes in the terminal soaks in the glass illustrate the practical importance of managing effects of real applicants. Phase change further demonstrate is that the matter absorbs or releases energy without changing temporal while transporting better in the solid, liquid, in gaseous states. This transformation rarely on the latent head and the current governed by molecular interactions, as shown the heating curves in the phase diagrams. Importing thermal straits in the phase chains and interconnected. pays the transients of the volume. In volume, abrupt volume changes the genetic internal stresses, while uneven heating can conduce locally phase changes in the structural fiber. And in summary, understanding these phenomena allowed us the prolific material in behavior, prevent structural damage designs safer in the more efficient and systems explain countless processes in the lightning life. Sorry. The relationship between head and straits in the face también transients hijo de lactics in the essential roles of the sequence in any ring technology and natural world.
Now we're going to explain an exercise. A steel disc has a square hole in the center with a 5 centimeters side when it is at 40 degrees. A brass bar has a square cross section of 5.003 centimeters at a temperature of 40 degrees. At what common temperature should they be so that the bar fits exactly in the hole of the disc? First, we are going to write the final length condition. The bar must fit exactly in the hole, so their final sides must be equal length multiplied 1 plus this formula, and that equals the length b. That is the exact same. We are going to substitute the initial length. I mean, it gets like this. Now we expand both sides. It's going to be 5 centimeters plus 5 centimeters multiplying this, that equals 5.003 centimeters plus 5.003 centimeters. The fourth group terms with the delta temperature on one side, constants on the other. Now we are going to put 5 and 5.003 to the other side to get the initial temperature. We take the factor out, like I just said, and we divide that those two. Now we are going to insert the coefficients of the steel and the brass. When we do that, we can calculate the final temperature. The initial temperature is 40 degrees Celsius. 40 degrees multiplying for 40 degrees equals T equals 40 plus the differential of temperatures that equals minus 35 degrees.
During the canning process of mineral water, a head space must consider allowance for the liquid's expansion to temperature change. Assume that the water is consumed at temperatures of 40 and the liquid similar to water. The original volume of the aluminum cyanide 354 ml. The coefficient of volumetric expansion for water aluminum are 2, 1, 10, 4, and 7, 2, 10, 5, respectively. What water volume of water should be contained answer 352 785 ml. 1. Write the expression for the expanded volume of the aluminum can. Buchanan final A01. 2. Insert the values. B can final 354 1 more 7 2 10 5 40 3 3. Compute the temperature change. Delta T 25. 4. Calculate the expanding can volume. We can final 354 1 T 2 10 5 25. Great expansion for the expanded volume of the water. View water. Final. B file 1 water delta T. 6. Insert expansion coefficient of water. Water final. B file 1 2 1 10 4 25. 7. Sum the final volume square. Water must extend the can fill 1 2 1 10 4 25 become final. So the first file volume 45 volume. 8. Answer a file 352 785 ml. Ahora ahí va el otro, ¿no?
¿Voy yo? Ok, voy yo. Un momento. Concrete breaks the deck is 500 meters long and the temperature in of the 1950 during summer in the temperature range in 2056. In the winter, in the drops to negative 10 C, the concrete has a linear terminal expanse confidence of the 1.2 for 10 negative 5 EC negative 1. Question. Calculate in the expansion of the brick deck from winter the summer conditions. Calculate the contraction of the brick deck from summer the winter conditions. Taking considerations of if these conditions. If expansion joins if expansion joins and the placer every 59 meters along the right, what the sum maximum gap h join to most accumulate. Real world application. Why is important to have properly served expansion joints and what problems could conquer the date were expansion from winter to summer. Use fórmula es igual a L O integral, integral 1.2 por 10 a menos 5 por 500 por 55 menos 0.3 metros. Time 1. Expansion from the winter to summer. Os alt time alt 0, 9. The formula is 1.2 for 10 negative 5 for 50 91 for 55 and 0.33 no 23 meters and 20 10 meters. Time 2 conversion from summer to winter. Convert two magnitudes in the same opposite sign formula negative 0.23 meters. Time 3 expansion joins seen with joins everything 50-10 meters. Interpretation A per segment expansion. If you divide the brain into segments of 50-10, so each segment is 50-10 meters long, the expansion of the 150-10 meter segments over the same formula is formula 50-10 time A for 50-10 or 50-50 time 0.0023 meters negative 23 meters per meters. So each 50 meters segment grows by is negative 23 meters. If joints are placed and everything every day is 50-10 interference in the edge joint must accommodate in relative movement of the segments against in the neighbor a gap. Time 23 meters is required. Interpretation B. Per interference conservative. If you count interference embedded in these 10 segments, there are 9 internal joins, and for 2020 2025 and 2010 time in 10 segments and 9 internal joins and total expansions 20 meters most the taking off by 9 joints to each joints void to allow 20, 20, 20 meters, 9 time 26 point 7 meters, point 99 2010 meters in el time at 20 30 36.7 meters. So a conserved per joint gap time at 26.7 meters. Testing recommendations. Use the directed more conservative valued and end margins for constructions tolerance, creep or bearings, swelling material compressions, frost heaven, possible future repairs, and safety factors. It specific in the nominal joint cavity of time for 410 negative four or 5 meters per joint. También lo este, ¿no? Okay. Why probably seized expense joints are important, brave. The joints after too small or missing terminal expansion will produce leg compressions. Straight in the retaining forces in the can cause baking or lateral deformance of the deck rails, cracking in spooling the of conceivers into structure the damage faulty or bendings anchors of pierce, fatigue, or fracture, directions of the legs producing bombs or reeling surface in the accelerated war, leaking through demic sails, leaving the horizon of reformant, and increases maintain cost and possible services hazards, probably sites joins allow the structure to expand contract without introducing demanding stresses, include them drinking sales in little extra gap of tolerances. Quick summary numbers. Total expansion winter and summer 0.23 meters, negative 20 10 meters. Constructions summer and winter negative 0.23 meters. Expansions for 50 10 meter segments time 23 meters and concert gap for internal joint 9 joints 26.7 meters and recommend specific for 410 negative 4.5 meters nominal joints capacity allowing safe E and tolerance margin.
Okay, okay, everyone. So that was all of our time, and I'm really wondering if you really understood anything that we said. Uh, I'm gonna be honest. Mm, It was pretty hard to do this to make it last 40 minutes. I hope you enjoy it. I hope you really like it. And if you don't, well, we we did our best. So cheers, mate.